And this one is just the badass one. This is so good, in my opinion. So here we go. This one is plutonium. So when I look at plutonium in this case that we're looking at is we're looking at 238. And when we look at 238 plutonium, what we find here is that there is something wild about plutonium. And here we go. Check out this image. And you look at this image and you're saying, man, that's really bright red. Well, it's actually red hot. It's really hot. So the question here, why is this red hot? And what you find here is that this sphere is an oxide of 238 plutonium that has a half-life of 88 years. So what do I mean? So in radioactive decays, we typically don't measure lifetimes. We measure half-lives. We could measure lifetimes, but it turns out that that's harder. So what this means here is that after 88 years, only half of 238 plutonium atoms are still in existence. And what I mean by that is imagine that you start off with 100 of these nuclei. So after 88 years, you now have 50 nuclei. And then if I continue the process, then I get to 25. Then I get to 12.5. And you could see that I'm just going to continue this process. And and after a while, all the number of 238 plutonium atoms are gone. So what you find here is that with the half-life of 88 years, it lasts a long time. So the question is, why is this thing red hot? So 238 plutonium is a good decayer. I don't think that's the way you spell decayer. I don't know. Yeah, I think it is. Decayer of alpha particles or of alphas. So its activity, maybe I should say it has a large activity. And that's literally the language that you use in nuclear physics, which means it emits numerous alphas. That collide with other oxide atoms and produces heat. And as a consequence, the sphere turns red hot. So you might say, okay, so this thing is emitting so many alphas that collisions with the other oxide atoms that you generate so much heat. So what's useful to this? Well, what's useful is that I think about two applications. So here's two useful applications. So the first one that I would think about is that I want you to think about space travel. So if you think about space travel, sort of like you're sending a spacecraft to Jupiter or Saturn, they're going to be sending them to the what is it? The moons of Saturn. You know, I think in the next few years. So in space travel, if one is very far from the sun, one cannot use solar energy. Like if you ever looked at the Hubble Space Telescope, it relies primarily on solar energy from the sun because it's close enough. But what if you're far away? If you're far away, you can't depend on solar power. So what you find here is that you use these plutonium spheres. So these 238 plutonium spheres are used to power electric circuits inside of spacecraft on long voyages. And what they do here is that the heat produced is turned into electrical energy, which means here it now creates a voltage like a battery. In fact, there's a name for this. So when we talk about this, the generation of this voltage is called a thermoelectrical generator. So if you live in the mountains, for example, you may have a generator. That generator typically runs off of, it can run off of three things. It could run off of gasoline, and it could also run off of natural gas or propane. But either way, you're using this heat here to produce electrical energy over a long period of time. And my neighbor has a pacemaker, and they just replaced it. And so what they find here is that these, if I could call it this, these plutonium batteries are used in heart pacemakers. And there's a huge advantage to this because I've known people who have pacemakers that in the early days where they had to replace the batteries, I think it was in the early days, if I remember correctly, I think it was every 5 to 10 years. So think about that. You have to go into surgery. They have to essentially cut you open and then replace the battery. But if you have these plutonium batteries, we know that they last, for many, many years, that never need replacement. But again, what's it emitting? It's emitting alphas. Now, the sphere has a high activity. You do not need such a high activity for a heart pacemaker. It's a small battery. But remember, alphas are what? They get stopped really easily. So therefore, it doesn't hurt you in the long run.